Good morning. Let's go and get started on chapter 3. Let me just make some settings here. Just trying to see everything looks good. Um, yes, I'm just making sure that recording is taking place. All right. So this chapter 3 is about decision structures and Boolean logic. And this is where we discuss the control structures. Typically, you will find in every textbook, there are 2 or 3 chapters discussing the control structures. The control structures are basically the heart of the coding, heart of the programming. You'll find typically in most of the textbooks, decision structures such as if analysis and switch case, they come first. Then the looping and repetition, they come in the following chapters. So we might find a similar kind of setup here in this textbook as well. So as you can see, chapter 3, and typically in most of the textbooks, around chapter 3, we discuss decision structures even in other programming languages as well. If you're taking Java, C++, or Python, or even many other places as well. So we are actually right on target. So in this chapter, what do we learn? So we will learn what are the decision structures, and typically there are 3 of them. And some languages might have some additional one, but if you master 1 or 2 of them, you will be able to make any kind of decision in coding. Then there are dual alternative decision structures, comparing strings, nesting, compounding. Then there's something called case structure, especially it's called switch case. There are different types of operators, relational operators and logical operators. We'll look into those and you'll find them in almost all the languages, and the Boolean variable comparison as well. And finally, probably in the middle of the chapter, we'll actually have a discussion about what the code looks like in these 3 respective languages, Java, Python, and C++. Just like in last chapter, we talked about and I demonstrated some of the code. So here as well, we'll look into if analysis and maybe in switch case for all 3 of these languages. All right, so let's go and get started. So a decision structure, it's also called selection structure. You might also hear from some instructors if analysis, if or else. So allows a program to perform action only under certain conditions. Basically, you're looking at the condition. If the condition is true, you do something. If the condition is false, you do something else. So based on the condition, and we can check the conditions in a variety of different ways based on the relational operators. There are 6 of these relational operators. We'll see them in next couple of slides. So if the condition is true, and that's called Boolean decision making, whenever something you're checking for true or false, that is a Boolean decision making. So then the condition is true, I want to do something. If the condition is false, I want to do something else. And if you look at your own life, that's exactly what we do on daily basis for everything we do. Do I want to wake up? Condition is true or false. Do I want to brush my teeth? True or false. Do I want to go to work? True or false. Do I want to complete this project? So you're always making the decision based on some condition. The condition is true, and could be multiple conditions, not only one, but you can have a condition based on decision based on multiple conditions. So not only one condition, but 2 or 3 or 4. That's where the logical operators will come into play, and we'll look into those as well. So different types of decisions include single alternative, a dual alternative, and case structures. So we'll look into all these examples in next couple of slides. So here is a pseudocode of how do we use if statement. An action only occurs if the decision is true. Remember that one. So this is always the case in programming. The action will happen if the decision is true. Again, you can have decision or condition, just not only one, you can have multiple of them. So here in this case, here's the condition. If this particular condition is true, then I will run these statements. Though these statements could be simple print statements, or these statements could be much more complex as well. but I can only enter the body of this if structure, which is the body over here, immediately after then. By the way, we don't use in modern languages the word then. In the past, in basic language and in the past many years ago, we used to use then, but here, just for the pseudocode purposes for plain English, this one is shown here. So here, these two statements will only be executed if this particular condition is true. If the condition is false, the control of the code will come immediately after end if. Whatever the statements you have, lines of code you have after end if, that code will be executed. And this code inside the body of the if condition structure will be skipped. So and how do I represent this pseudocode or this particular condition checking in flowchart? We use a diamond symbol. We didn't use this diamond symbol in the second chapter, but the diamond symbol is being introduced here. This is what it looks like. So whenever you see a diamond symbol, it means we are checking some kind of condition. For example, let's say the condition we are checking is it cold outside? If the condition is true, then I will go on the right-hand side and I'll say, here is my wear a coat. Some kind of action is being taken, a process is happening. If the condition is false, as you can see underneath here, then I do not need to do anything. I can just not to wear a coat. So let's move on. And so there are six operators, and these six operators are called relational operators. So they determine whether a specific relation exists between two values or not. Those could be two literal values, or those could be two variables, or one variable and literal value, or even in some cases, we can call other functions, and those functions can return some kind of value back to us as well. But in order to have, in order to check those conditions, I can check if something is greater or less than, greater equal, less than equal, equal equal. This double equal sign is equality symbol. The single equal is not equality in most of the programming languages. Single equal is an assignment. You assign something. For example, when you say x equals to 5 with a single equal, then it means you're assigning the value, the number 5 to variable x. But if you say x equals 5, that now you're checking if the value of x is equal to 5. So there's a difference. So unfortunately, in mathematics, we do not have different operators. We just say suppose or let. But in programming, in order to differentiate these two operators, so this double equal in most of the programming languages indicates it's an equality. You're checking an equality between two sides, left side and the right side of an equation. And the last one is not equal, which is an exclamation mark with an equal sign. So you're going to see the application of these six relational operators in various places, and we'll look into those just in a bit. So, and that these are, they determine whether a specific relationship exists, and they're used within the condition of Boolean expression. So what is a Boolean expression? Boolean expression is that's where you're checking a condition. For example, if you say, um, do I have $50? So that's a Boolean expression. It could be true or false. Am I hungry? That's a Boolean expression. Is it true or false? So that's a Boolean expression. So if then else statement executes one group of statement if its Boolean expression is true, or another group if its Boolean expression is false. So here temperature is less than 40, true, do this on the right hand side. If the temperature is less than 40, not less than 40, the condition is false, then we go on the left hand side and we execute something different. All right. Again, we are still working on pseudocode. This is not a real code from any specific language. So if condition is true, if this condition is true, I will do this. Sometimes I also want to make it nested statements. Nested statements means maybe I want to take another action if the condition is not true. So this condition becomes false. Remember, initially I said if the condition is false, I will go right under add and if. But what if I want to execute some statements, some steps? I want to do something if the condition was false. So if this condition is false, then it goes to the else part of it. Else by itself cannot exist. Else cannot be implemented by itself. It must be part of the if structure. So if structure is allowing you to check the condition. Based on this condition, if it is true, do this. If this condition is false, then do these statements, do something else. And this is where the end if statement ends over here. All right, let's look at the application here. If the temperature is less than 40, that's my condition, then I'm going to do these two things. If my temperature was not less than 40, then I will do something else over here. And the end of the structure happens right where end if. Again, like I stated in Java and C++, we do not use end if. In some languages in the past, we did use them. But here you'll see some of the modern languages do not use end-if. Again, most languages allow you to compare things. So if password equals, take a look over here. So you grab the password from the user gives you the password, you're grabbing as an input. Then you're checking if the password equals. Remember, the double equal is necessary to compare two things. Single equal cannot be used for comparison purposes. So you're comparing if the password equals to this, then password is accepted. Otherwise, not a correct password. And again, you can see the implementation or execution of the code right under here. And then we'll look into the real examples just in a bit. Similarly, you can also compare strings. You can compare name1 equals name2, or you can compare such as month. Let's say month is a variable, has some kind of an ability to store some kind of string or textual data. Then you can also compare if the month is not equal to, this is not equal to October, then I'm going to take some action. So string comparisons are generally case sensitive. So here, take a look at this one. This is uppercase O. So if your month is lowercase October, all letters are lowercase, then it is going to say it's not equal. Technically, in our head, we thought it would be equal, but because the letters are case sensitive, so it might give you the wrong answer. So you have to be very careful when you're comparing strings. Again, you can also determine whether one string is greater than or less than, or any one of the other comparison or relational operators we can apply. Decisions are nested in order to test more than one condition. It is possible. You want to check grade is an A, grade is B, grade is C, grade is D, grade is F, or grade is unknown, or whatever. So in that case, you can apply something called nested condition structure or nested decision structure. So in that case, for example, take a look over here, salary is greater than 30,000. I'm going to do this. Yes or no, years on job. And as you can see, the second set of conditions over here. If the condition is true, I go on the right-hand side. Condition is false, I go on the left-hand side. So you can actually have nested decision-making ability. And we'll see an example over here. And I use an example of grade. Here is using an example of score, which is almost identical. So here, if then else, if statement can make nested logic simpler to write. So you can say if score is less than 60, then that person got an F grade. Otherwise, we go to the else part. And notice that immediately after else, there's a space here. So many of the languages, there's a space. Some languages, there's no space, but Java, C++, you'll see there's a space. So there's a space here. Then you check the second set of condition. If the score is less than 70, grade is D. And you can argue, how come you're not checking the second condition? What if somebody got a score of 50? If somebody got a score of 50, they will be already under here. They will not be able to get to this part here. This will not be impossible because once this particular condition becomes true and this person got an F, then they will not be checking the second else, the third else, the fourth else, the fifth else. They will immediately exit this structure after end if. So just remember how the flow of the code happens. If the first condition was true, let's say somebody got less than 60, 50, 40, whatever is zero score, and then this will be executed. And immediately after that, none of the other conditions will be tested again. There's no need to test the rest of the conditions. And in fact, the control or the flow of the code will go immediately after end if. Now you can only reach here if somebody has score greater than 60. Somebody got 61. So 61 is still less than 70. And then we can say, well, this person got 70. If somebody got, for example, greater than 70, let's say 75. So 75 is less than 80, and on and on. And this particular logic can be applied in various different ways. This is not the only way you can check that condition. You can also check in other ways as well. There's another structure very common in many languages, and that structure is called case structure or switch case structure. And the case structure lets the value of variable or an expression determine which path of execution the program will take. Can be used as an alternative to nested condition. So the if and else's are the most powerful condition or selection control structures, but there are other ones, switching case. Although the switching case in some languages has some limitation, in some languages, it doesn't have the ability to compare strings or double data type. It only allows you to compare integers or characters, single characters, not textual data, not the names, not the city names, and those kind of things. But it's very useful. That's what we are trying to look over here. Can we use an alternative? So sometimes it has a nice structure. So you probably want to use switch case, and we'll see some of the real examples a little bit later. So we come back here and we compare the month. And if the month, let's say the incoming value is January, so the incoming value is compared here, then the case one will become true. If the case one is true, month was January, we'll actually go and do something about it. Otherwise, it's going to compare with other cases as well. And again, this particular example is not very effective to understand how it works. We'll see the real example just in a bit. All right, just like your relational operators, there were 6 of them. There are 3 logical operators. And these logical operators, they have specific symbols. They have specific, they look different. But here, just for sake of understanding for pseudocode, we call them and, or not. But in many languages, in C++ and Java, for example, this is what the and operator looks like right there. And for or, these two pipe symbols, this is your or operator in many languages. And for not, not is this operator here by itself. So although these are the operators which will be applicable and implemented in a code, but for sake of understanding right now, we'll just stick to and. So in case of and, all conditions must be true. You have 2 or 3 or 4, all conditions must be true, otherwise nothing is true at all. So these are the logical operators used between conditions. So you have multiple conditions, like I stated earlier as well. And I always use an example. Let's say the 2 conditions we have will go for movie and will go for coffee. In that case, we are putting and in the middle. It means both conditions must be true. In that case, if you decide not to go for a movie, then there'll be no coffee, or vice versa. If you're not having coffee, then there's no movie as well. And dictates all conditions must be true. And there could be 2, 3, 4, many conditions as well. In case of or, only one condition needs to be true. So either condition must be true. Either the first one is true or the second one. So or is very flexible. So we say we'll go for movie or we'll go for coffee. Either the first or the second might be true. And that not operator reverses the expression. If your condition gives you the answer true, it makes it false. And you say, well, why do I need to use it? In fact, we use it very effectively and in our daily lives as well. And operator is very effective and it saves us a lot of time for not checking unnecessary conditions. So here's an example of AND operator. So AND is applied between the first condition. Here's my first condition. And here's my second condition. There are two conditions here. Both must be true. Temperature must be less than 20 and minutes more than 12. Then you can execute the statement inside the body of the structure. In case of OR, only one condition needs to be true, not both. If the first one is true or the second one is true. In case of not, notice that if this was true, temperature is greater than 100 degrees. And because we are applying not, then it reverses it. So it makes it, if temperature was, let's say 110 degrees, not makes it below the maximum, which is reverses the condition. And again, this is not a good example for not, but it's very effective and useful. Now, there's a concept called short circuit evaluation. It's supported by many languages for increased performance, especially when it comes to and or operator. If the expression on the left-hand side, let's say you have 4 or 5 conditions and all must be true in case of and operator. Remember, and requires every condition you are evaluating must be true. Let's say the first condition is true, false. Then technically it does not make any sense to check the second, third, or fourth because the first one was false. So this is called short circuits. The program compilers are smart enough. They will they will actually make you exit that particular scenario because there's no need to waste your time and resources and compute time and processing time. They will not be checking the second, third, and fourth condition. That's what it's saying. If the expression on the left hand side of the and operator is false, the expression on the right hand side will not be checked. There's no need to check for that one. And same thing applies for or. Imagine if the first one is true and the second, third, fourth are all false, it doesn't really matter because OR is so flexible. There's no need to check for the second and third. The overall condition becomes true in case of OR. All right. You can also check the ranges, and these ranges allow you to check with and or operator. You can say if the value of x is greater or equal to 20 and the value of x is less than equal to 40. And if you can also apply for or operator, and your imagination is the limit in this case. So you can apply many different situations. So variable for the Boolean data type can hold one or two values, true or false. So let's say we declare a variable Boolean. In many languages, such as Java, you write the full word Boolean. In some languages, you can simply write bool, B-O-O-L. So here, this is lunchtime is declared as Boolean. What does it mean? It means it can hold only two values, either true or false, nothing else. All right, so if the time is greater or equal to 12, that's my condition, then I'm setting the value true for lunchtime. Otherwise, I'm setting the value false for the lunchtime. So you can hold true or false for Boolean data type. All right, let's look at the real examples in these three languages. Here is our Java implementation. Look at the relational operators. They are exactly how we indicated earlier. And this is also true in C++ as well. So you have a greater symbol, you have less than symbol, greater equal, less than equal. Equal is equality symbol and not equal. All right, let's look at how we apply if condition in case of if. All right, so assuming this is some kind of condition. Now, this condition could be you are checking equality, not equal, greater, doesn't really matter. It's a Boolean expression, assuming some kind of first condition is being checked here. So if this condition is true, this is the body where it begins. This is the body where it ends. Remember, initially we were showing else if here, and in fact, I want to go back one more. couple of more steps. Here, you can see there's a then and there's a and if. In Java, there's no such thing. In Java, the body of if begins with the curly brace opens and the curly brace closes. That's where the body ends. And this is applicable to many languages as well. So if this Boolean expression, this condition is true, these statements, either 1 or 10 or 100 statements, will be executed inside the body. Or if you have just one statement underneath here, you do not need the curly braces. Although technically you do not need the curly braces, I recommend highly, to avoid any logical issues in the future, make as a habit, always use curly braces. Curly braces are lifesavers. They actually allow you to enclose your statements within the curly braces. So I do recommend highly, even in this case, I would recommend you use curly braces, even if you have just one statement inside here. All right, let's look at this example for else. If this condition is true, I will do this. Otherwise, I'll go to the else part, and then I will do this. Notice that there's no end if. There's no end if. The structure of if is controlled by the curly braces. There's no need for then and end if. And if you have just one statement, I disagree with this one, although this works, but I always recommend, even if you have just one statement, always use curly braces, because programming is always adding and deleting. So in the future, if you want to add additional statements, there's less opportunity to make any errors. So else is always lowercase. Else is a keyword in these languages. So it is always lowercase. All right, comparing strings in Java. Now, the way Java compares strings, there are some functions available. The functions are a set of collection of code developed either by somebody else or by you. So this is a function given to us. This is not the function I have written. So we can use dot and equals. So you can compare the value of string 1 with the value of string 2. You can compare, are they equal or not? This is the function. This is the function call. And this is how you can compare. So for example, you have some kind of password you captured from the user gave you that password, or in this case, the password is stored here, and you're comparing these two passwords, the password which is stored right here inside the code and this password. What do you think? Are they equal? Answer is no, they are not equal, because this is uppercase P and this is lowercase p. And remember that textual data is very case sensitive. So, and in that case, if they were equal, it will display password accepted. If they're not equal, it will say password is not accepted. All right, let's move on. A couple of more examples. You can also compare to determine whether string 1 is less than, equal to, or greater than string 2 using the following notation. There's another function called compare to. So if the expression returns an integer value that can be used in the following manner, if the expression value is negative, if the result based on this particular condition is negative, the string is less than, string 1 is less than string 2. If the expression's value is 0, the strings are equal. If the string value is positive, there are two is here, is positive, then the string 1 is greater than string 2. So this one is slightly different from equals. So remember, in equals, it just checks if these two particular strings, string 1 and string 2, are equal or not. In this case, it compares the values which is being returned, minus value, 0 value, or positive value. If the negative value indicates the string 1 is less than string 2, and 0 indicates the values are equal for both strings, and the positive value indicates string 1 is greater than string 2. In some cases, you probably have to do that kind of comparison. You can also compare in such a way, you have two variables, name 1 and name 2, and you're using the same compare to. equals 0, the names are the same. If not, and you can also use one variable with literal data. Literal data is the data which is literally that what it looks like. So then you can also compare, and if the answer is equals to 0, then of course you will say names are the same. Otherwise, if the names are not the same, based on its negative or positive, it will tell us. So I indicated the switch case. Switch case is an alternative to if analysis. Can I embed my switch case inside if and vice versa? Can I embed if and else inside the switch case? Absolutely, you can do so. That is a little bit more advanced coding, but you can embed multiple structures within as well. But this is what the switch case looks like. You have an incoming data for month. So month will be provided to you either from the user, from some kind of source. Let's say the incoming value of the month is March. So incoming value is March. Then it goes and checks each case, each case. So I'm sorry, let me correct myself. If the month is 1, 2, 3, the incoming value is, remember I had indicated that switch case is limited. Switch case typically compares the integers or whole numbers or individual characters. It doesn't have the ability in many programming languages to compare, to take the data as string data or double data type, real data. But let's say the incoming value is 3. For month, if the value is 3, user has provided this value 3, or you have picked up this value from a database. So the data, incoming data is 3. So it doesn't match with case 1 because case 1 is not 3. Doesn't match with case 2, that's not 3. It matches with case 3 because that's what the month was, 3. So it matched with this 3, then it will display month of March. It will print month of March. And then notice that there's a break after that one. I personally do not like it, but this is how it is, and there's nothing I can do to change it. This is where the legacy programming used to be when we wrote code in 60s and 70s and early part of 80s, but this is how it is. So for each case, you must break out by calling a break keyword. Break keyword forces you to exit the structure. Where is the structure? The structure of switch begins here. The structure of switch ends over here. So this break, wherever it finds the break will force you to exit this structure here. Whatever comes after switch structure, that will be executed after that one. Now, let's say the month of value of month is 14 or 15 or whatever, and none of these cases match the criteria. Then it goes to the default, and the default will tell you the invalid month was presented or added. All right. So how do I apply logical operators? Remember, I had indicated and, or, and not. This is your and symbol, two ampersand signs, two pipe symbols, and this is exclamation mark. So this is your not, this is your or right there, and this is your and. And this is also true in many other languages as well, which we'll see that a little bit later. All right, so I can say, here's my condition 1, x is greater than 20, and x is less than 40. We did something similar earlier. In that case, do this. And in case of or, this is your or operator, and it will either condition could be true, and our overall result will be true. Now, again, we did this one earlier as well. And how do I apply this one? If the temperature was, let's say, 200 degrees, 200 is greater than 100, and then you reverse it. You reverse it by saying not. Again, this is not a good example, but it could be used in many good examples as well. So Boolean variables in Java, you can use the Boolean data type to create Boolean variables. A Boolean variable can hold one of two possible values. Remember, you can only store true or false. So here you create high score as a Boolean data type. And if the value of average is greater than 95, the high score becomes true, or you can store true. Notice that this is an assignment operator, so you store true in this variable. Otherwise, you say that's a high score. You can also say that one. All right, and let's look at some of the usage in Python. Same exact six relational operators. I do not need to spend time on that one. Notice that this application of if is slightly different, very slightly different in Python. So if I go back, just let me go back a couple of slides, few slides earlier. All right, right there, here. Take a look here. So here, this is how we applied. You had a curly brace here. For the body, you have curly brace here. There's no colon at the end. In case of Python, it is you can see right there. And then there's no need for curly braces. Although I can force myself and use a curly brace, but there's no need in Python. So that's a very small variation. Also notice there's no need for the parentheses, which I do not like in Python. I think the parentheses give you again, this comes from so much experience from coding from so many languages. It gives you much better control, but this is how it is. So this is how you can write a condition, a simple condition. If this condition is true, these statements will be executed. If the condition is false, none of these statements which are indented, indentation is necessary in this case, and then it will go immediately after that one. And we'll see some other examples now. Here, if the condition is true, all the indented statements will be executed. If the condition is false, then these indented statements will be executed. All right, so relation operators can be used to compare strings in Python, just like what we did saw earlier. So here is the same one, equal, equal. Notice that there's no parenthesis here, no parenthesis to close here. If these two names equal, we say names are the same. If not, we'll go to the else part and we say names are not the same. Again, I'm going a little faster in this one because this is identical to what we just did. The only difference is missing parentheses and adding colon at the end. And these are and, or, and not. Notice that in Java and C++, we use ampersand sign twice, pipe symbol twice, and an exclamation for the not. Here, you are using lowercase and, lowercase or, and lowercase not. Let's take a look at how we apply it. And here's your condition one. We saw this condition a couple of times earlier. Condition two, and is used. In case of Java, we use two ampersand signs. And here's your or operator, and here's your not operator. Okay. And Boolean variables in Python, a Boolean variable can hold one or one of two possible values. True, uppercase T, true. In case of Java and C++, it's all lowercase, but in this case, it's uppercase T and uppercase F for false. So we declare, remember, in Python, we saw in chapter number 2, you don't have to declare it. It automatically figures it out. So you're storing a Boolean data type in this variable here if this condition was true. If this condition was true, otherwise it will be storing false if the condition was false. All right, let's look at the implementation in C++. Same exact six relational operators, no difference whatsoever. We'll move on. And just like Java, you have parenthesis, curly brace and curly brace close. Hardly any difference whatsoever. Hardly any difference at all. I had indicated that I will probably always have curly braces, even filled with one statement inside the body. I have indicated that earlier as well. This is almost identical to Java as well, no difference whatsoever. So imagine if you learn Java or C++ and you go to another programming language, you can read the code without any difficulty. You can write the code without any extra effort at all. So in case of switch case, so it's identical. Curly brace opens here, curly brace closes here, month, and there's no difference whatsoever, as we saw earlier in Java as well. And same thing with the default is also there. I don't need to further explain. These are the same exact operators we saw in Java. Notice that Python, the operators were stated as and, or, and not. In case of C++ and Java, they're exactly the same. And implementation is exactly the same as well. You say, well, why do I need to learn other languages? Yes, you do need to learn other languages because they have their own market and industry, and they have their own variation as well. But these application of these operators are exactly identical. And here you can also say bool, and in C++, you can use the bool data type to create Boolean variables. I think this is a mistake. You can also call it bool right there. And then you can simply assign the value to that variable. Otherwise, you will say the score is, if this was true, score is high score. And that's it. We are done with chapter number 3. And I think this was a brief chapter. This chapter allows you to learn all the skill set, and hopefully we'll learn some more stuff in chapter number 4. All right. I'll talk to you guys later. Bye-bye.